Hello, and thank you for joining us. Today's webinar topic is Troubleshooting NA Purge and Trap, presented by Amy Nutter, VOC Technical Product Specialist for Teledyne Tekmar. This webinar is being recorded and will be available within a few days. If you have any questions, feel free to submit them using the question feature, or you can email Amy directly. She'll provide their email address at the end. Now I'll turn it over to our presenter, Amy Nutter.
All right, thanks for the introduction. Like she said, I'm Amy Nutter, Technical Product Specialist for the Purge and Trap product line here at Teledyne Tekmar. And today I will be giving you tips on how to troubleshoot any Purge and Trap. So thanks for joining me today. I'll go over a quick little introduction to Teledyne Tekmar and our products. I will give the troubleshooting tips, but a couple different topics. And I'll show you some tools that you can use if you have a Tekmar product that can aid in the troubleshooting process of a Purge and Trap. And be sure to submit any questions you have, and I'll be able to answer you by email. Teledyne Tekmar has been around since the 60s, creating the first commercial Purge and Trap concentrator in 1975. We're the market leader for Purge and Traps in the US, and we offer several different options. The Lumen Purge and Trap concentrator, shown on the right, is our standalone waters-only concentrator that can be paired with the Aquatech LVA autosampler. We also have the combined autosampler and Purge and Trap concentrator, the Atomics XYZ, which is shown on the left, and that's capable of analyzing soils, solids, and water samples. We also manufacture other elemental analyzers as well. So a little outline of what we'll be covering today in our Purge and Trap troubleshooting. We'll cover no response from your analytes, carryover and contamination, elution issues, middle, early, and late, water interference, internal standard recovery variability, linearity and reproducibility issues, and then our two TechLink tools that we have to help with troubleshooting will be the system leak check and the benchmark test that I'll also go over. So first, the manual can help and assist you with troubleshooting issues because it has some tips in there and, of course, flow diagrams. If you have a Tekmar product, the manual can be accessed in the help on the main screen of TechLink. And when you start to look into troubleshooting your instruments, we want to examine the facts and use valid reasoning, meaning you want to look at your data. You want to use those flow diagrams. You want to get a feel for what's going on. If you have missing peaks, little to no response, or issues with your internal standards, that might help you identify the root cause of the problem, whether it's coming from the GCMS, or the Purge and Trap, or the autosampler. Of course, quick fixes might burn you in the long run. You don't just want to fix everything all in one go because that could get really expensive. Try to do one thing at a time so you can really narrow down where the issue is. And in the long run, that'll save you a lot of time and money. So just be patient with this troubleshooting and try and fix it right the first time. You want to identify the root cause. You want to find the root cause. So how we do that is we split our system up into 4 separate entities. So here we have your detector, mass spec in our case, the GC, the Purge and Trap, and the autosampler. And you always want to start your troubleshooting with the detector and then work your way down to the autosampler. In order to eliminate the GCMS, it's not necessary to disconnect the Purge and Trap because it's cut into the inlet line of the GC, that carrier gas line. And you want to confirm normal operation. You want to make sure that it's passing the BFB tune. If you see poor chromatography with a direct inject, you know that the problem lies within the GC, in the liner, or the column. Now, once you confirm it's not the GCMS, you can then proceed to the Purge and Trap. In order to eliminate the purge and trap, first thing we want to do is we want to run a leak check. It'll help you identify a leaky valve or a connection that's not leak tight. You want to make sure that you have the correct analytical trap in place. You can always tell by the little number or the letter that's on the nut of the trap, and you want to make sure that that is the correct trap for the method you're running. Some traps don't retain and release certain compounds, so if you don't have the correct trap in for the method that you're running, you won't be able to see those compounds in your chromatogram. A good tip for troubleshooting your trap is to have a good reference trap available, one that you've tested, one that you know that works, and then you store it properly and bring it out for troubleshooting situations. Switching traps to one that you know works will help you determine if it is a trap issue. And then in order to eliminate the auto sampler portion, you can manually load your samples into the sparger. So if you're dealing with no response from your analytes, first you want to know if the analytes are getting to the GCMS. Is the trap heater reaching the correct temperature set point to desorb those analytes off the trap? You can always double check this on the status screen if you have a Tekmar product. Also, you want to check the desorb flow in your method, because if you don't have the correct flow settings for the trap that you're using, you won't be getting all of those analytes off of the trap. Next, you want to check the 6-port valve that sits on top of the instrument. You want to make sure that you can hear that valve actuate. You'll know that power is getting to that valve and is actually rotating on the inside. It's possible that the 6-port rotor is installed incorrectly because the transfer line coming out of the purge and trap, it's a constant loop that is broken off from the purge and trap in the GC. This is where your inlet flow circulates through your transfer line, and if it happens to be off by 180 degrees, you'll see a decrease in that front inlet pressure that could be causing little to no response from your analytes. In order to check the purge and trap and the auto samplers, are your analytes getting to the trap? Is the sample being pulled and being transferred to the sparger? Do you see, if you don't have the correct amount in the syringe or in the sparger, then that could be an indication that you're not getting that transfer. Sample valves or drain valves could be leaking. They could be leaking across the port of the valve, and you might not be getting the sample recovery that you're expecting. So if you think you're losing sample, this would be a good place to start, a good place to check. Do you see bubbles in the sparger, for instance? If there's no bubbles in the sparger, do a leak check. Once that passes, make sure that your flow is set correctly for your method. Typically, EPA methods have guidelines for this, like Purge at 11 minutes for 40 mils a minute. It's pretty standard across the US. If you don't see those bubbles, start to work your way back. Do you have gas coming into the instrument? Have you recently changed the tank? Did you accidentally change the regulator pressure gauge? Regulators are typically set between 60 and 85 psi for purge and trap systems in GCMS. If all of this is set up correctly, then you might want to check the mass flow controller on the instrument. And if you have a Tekmar product, you can look at the status screen for an update on the flow, and you can measure the flow out of the vent on the manifold as well. So you just go into the tools menu, you set the flow in valves and flows, and then you measure it right out of the vent. Or you could check during purge if it's set for 40 mils a minute and you want to make sure out of the vent you're getting 40 mils a minute. So carryover is not just for those late eluders. It could be for your full target list, and contamination can be anything present in the sample that you're not specifically looking for. In order to track down, where this is coming from, you want to run a GC only run. So just set up a schedule, hit start on the GC, and that'll show you if there is carryover and contamination in your GC from the chromatogram. Or if the peaks you are seeing, are they carryover peaks, contamination, are they causing your results to be more than what they should be because they're getting carried over from sample to sample. And on the purge and trap side, you can go to desorb in tools if you have a Tekmar product. That will preheat the trap and desorb off of the trap to the GCMS to see if there's anything staying in that trap longer than it should be. You have to make sure that your temperatures are getting to the correct set point. If not, you might not be getting everything off of the trap, and that's why it's being carried over. And also you want to make sure that your bake temperatures and flows are set correctly as well. Bake is a very important step in cleaning up the system and preventing carryover from sample to sample. And lastly, we want to make sure that your hot water and your methanol rinses are working correctly as well. You want to make sure that that 90-degree C water is running through your sample pathway to clean it up. Make sure that you're pushing enough through the system. If you are using a 25 ml sample to purge, you want to make sure you're at least using 25 ml of hot water, preferably 27 ml in that sparger to help clean it up. And you can set multiple rinses if needed. It's optional in our Atomics XYZ to do a methanol rinse. It can rinse the entire sample pathway, which includes the syringe, associated transfer lines and valves, the sparger, the 3-stage needle, and you can also vary that volume and number of rinses as well. If you're having carryover of the full target list, you might have a faulty EPC on the GCMS. On the purge and trap side, if a valve is leaking, it could be leaking to a part of the instrument that's not going to be used until the next sample. So that's how you could be getting carryover from one sample to the next because what was leaking is now being swept into that next sample. You want to make sure that all of your temperatures on the status screen are getting to set point. If not, you could have a faulty trap heater. Not getting all of the analytes off of the trap or not getting it hot enough to bake out, that could cause the carryover. Also, the sample could not be draining entirely from the sparger, so you want to make sure that that drain line is all the way down to the frit. It could be not draining properly or leaving some of the sample in there for the next run. And also, your glassware could be dirty or not being rinsed correctly. And for the auto sampler, if you have the ability to compare a soil sample with a water sample, this could be a very nice troubleshooting tool. If you have a Tekmar product, these pathways are pretty independent of each other. Therefore, if one has carryover and the other one doesn't, that really narrows down where the problem in the sample pathway could be coming from. For example, if you see carryover in the water sample but not in the soil sample, the carryover could be coming from the glassware. If it's in the soil sample and not in the water sample, it could be in the soil valve or the needle or the soil sample lines. And we want to make sure the hot water rinse or that the rinses are hot enough to clean everything up. The internal standard valve could be leaking across the port, and this could be pushing the sample back into the internal standard vessel. And every time you add IS to the sample, you could also accidentally be adding a full list of compounds to carry over into that sample. For carryover of the late eluters, it could be a cold spot on the inlet. Compounds could gather and just sit there, being carried over into the next sample. Not enough bake time on the purge and trap might need a longer bake time. And this could be optimized with a carryover study. So just try a different range of bake times and compare them, see which one you like the best. In the auto sampler, maybe you need more bake rinses to really clean out from sample to sample. The sample needle could not be getting cleaned properly, so make sure you have enough rinses for that, or you could try the methanol rinse if you have that option, and make sure that the bake rinses are being transferred over to the purge and trap to get cleaned. If you're having elution issues, you want to check the tune on your mass spec, make sure everything looks normal there and passing. If you could do a direct inject into the GC inlet if you're missing any peaks, or you could have a bad EPC, or you might need to replace the column. You could also do a top of the trap injection if you're still missing peaks. It could be the tubing, the sample tubing, or the transfer line. Problems with early elution groups, you want to check the GC inlet. You want to make sure there isn't a leak or a bad column. And as for the purge and trap, you could have a small leak, so do a leak check. Leak in the trap could cause a loss of early eluting compounds. You could not be efficiently managing the moisture. Too long of a dry purge could be pushing too much water to the GC. This and too hot of a trap might push these compounds to vent, and you might not be able to get the recovery that you're expecting. If you're having issues with your middle elution groups, which is very rare, the GC column could need to be replaced, or you could have the wrong column for the method that you're running. The purge and trap flow might be too weak to push everything off of the trap to the GC, or there could be a leak in the mass flow controller, or you might just need a new trap. For issues with late elution groups, your GCMS might need source maintenance, or the carrier gas flow rate is too low. On the purge and trap side, you could be dealing with poor purge efficiency, restrictive tubing, dirty glassware, a faulty heater, or your vent valve might be plugged. Or you might just need a new trap. And for our water interference, why is water vapor bad for our analysis? It can minimize sensitivity. It can cause compounds to co-elute and shift in retention time. It can also cause poor peak shape, even in compounds that's outside of the water peak. So how do we deal with this water? On the purge and trap side, we can look into things like what kind of trap we're using. We want to make sure we're using the right trap for the method. The sample purge temperature. So purging the sample at a higher temperature can drive VOCs out of the solution better, but there are trade-offs regarding adding additional moisture to that analysis. Possibly the dry purge settings aren't optimized, or there's too much desorb time, or it's not desorbing at the correct temperature. We also want to look into our bake parameters as well. Bake removes the moisture that has been accumulating in the system during the purge and trap process from sample to sample. So make sure that we get hot enough, not too hot for the trap packing material, and our bake gas flows through the trap long enough to remove all of that moisture without, going for too long. A good bake gets all the water out of the trap and the moisture control fitting to make sure that it's ready for the next sample. On the GC side of things, we can look into the split ratio. So the split ratio might be set too low, allowing too much water to get onto the column. By using shorter, narrow bore GC columns, we can adjust our split ratio. So a higher split ratio means that that desorbing gas coming to the inlet and going off to vent, and less of that water is getting onto the column, um, or less of those analytes are getting onto the column. Therefore, less water is also going onto that inlet and onto the column. But of course, that means less of our target compounds are going to be there as well because they're going off to vent. So that's kind of the trade-off. But a long water peak may be a sign of a bad column as well, and it might be a sign to replace the column. And on the mass spec side, you could be looking at vacuum issues. If you don't have adequate vacuuming, then that water is getting to the mass spec and it's causing more problems than it otherwise would. Less water going onto the GC column means less water is getting to the mass spec as well, and this can extend filament lifetime and allows for less source cleaning, which is a huge time saver because that is a long process. For internal standard recoveries, for variations with that, you want to start and look at your GCMS response of your internal standards. Is that increasing as your target compound concentration increases? You could have a dirty inlet liner or a dirty source. You can validate this by preparing 3 increasing target concentrations with internal standards in 1 ml vials, and then you can do a direct inject of 1 mic onto the GC, into the GC inlet. If it's still increasing, you've at least isolated the active site between the source or the liner. So therefore, just perform the cleaning or perform the replacement, and hopefully that solves the problem. If the active site is not within the GCMS, it could be in the sample tubing or on the analytical trap. To check the autosampler, you can hand spike vials first, and then you can do a manual injection into the sparger. You could also check the pressure in the internal standard vessels. You can do that if you have a Tekmar product in the tools menu. There's a button for that, and you want to make sure that that is between 6 and 8 psi. For linearity and reproducibility issues in the GCMS, source maintenance might need to be performed. Could have vacuum problems, EPC failure, a bad column might need to be replaced, and the method might not be optimized. You could look into changing up your oven temperature program, or your multiplier might have gone bad and you need to replace it. And on the purge and trap side, your trap could be failing. Are the brominated compounds displaying a low recovery, or are your heavy compounds not recovering very well? Check if the internal standard is varying. This could cause those issues, or there could be an active site. The drain valve could be leaking, and there could be excess water in the system, so increase the bake time. Temperatures could not be reaching set point. Could have too much carryover from sample to sample, or could be dealing with sample preparation errors. In the auto sampler, it could not be pulling the same amount of sample each run, or not transferring the sample correctly. It could not be properly rinsing between samples. And again, you could use that comparing the soil and a water sample, because like I mentioned before, they have different sample pathways. So if you find an issue in one, that could be where your problem is coming from. And again, determine if your internal standard is varying and causing everything else to look unstable. So for tips to identify leaks before they become a problem, a little bit of warning signs if you'll have a leak in your system. If you have a steady or a very fast drop in the purge and bake pressures when you review them in the history log, that means you could have a leak. And some of these topics we've already kind of covered today, but to tie it all together, you probably could have a leak if you're missing or have a lower than usual response on your front end compounds like the gases. This can be especially true in soil mode if the vial cap isn't on tight enough, and I'll show you an example of that. If your linearity and reproducibility are off, you could have a leaky drain valve, which could lead to too much water in the sparger and not enough sample. If your sparger is draining very slowly, you could have a massive leak. Low to no sparge vessel bubbles could be an indication of a leak. And if your purge and trap is connected to a GC with a pneumonic inlet with pressure or flow that is electronically controlled, it'll alert you during desorb, and that means that you probably have a leak in the trap. So this is that example I was talking about with a leaking vial cap in soil mode, and as you can see, the loose cap is in black and the tight cap is in blue. So you lose a lot of response when your system isn't leak tight. A lot of sensitivity. All right, and here is the TechLink leak check diagnostic tool. So usually you want to run that leak check after you change the internal standard, the foam eliminator, any glassware, the trap, you loosen any fitting, basically anytime you change a part on the instrument. After turning the system back on after it being off for a while, maybe like a holiday break, and before performing a benchmark test, because you want to make sure that the system is leak tight for that. If not, the benchmark might say there's a failed purge valve when that might not be the case, and then you're going down a rabbit hole to try and fix something that isn't broken. And if the leak check fails, the overall leak check, it'll break down into 3 subsystems. And in the manual, that is accessed in the help menu of TechLink, it will specifically tell you where to look for the issue based on which subsystem fails. So that's a really good tool, troubleshooting tool, to help you narrow down where in the purge and trap there could be the issue. And the benchmark test is also a great troubleshooting tool. Like I said before, you just want to make sure that your system is leak tight before you start it. It checks all the system controls, including solenoid valves, heaters, flows, the 6-port valve, and it helps isolate a variety of potential issues that you might have and helps determine what might need to be replaced. So thank you so much for taking your time to join me today. Please check out our website for all of our latest application notes. You can view past webinars. Be sure to visit our online store. You can follow us on social media too. And there's my email for you to submit any questions that you might have, and I'll be sure to get right back to you. So thanks, and have a great day.